Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. If you watched my previous video on proving triangles congruent, you noticed that we did those based off of 3 sides and 2 sides in the included angle. Well, we're back today and we're going to be talking about what happens when you have 2 angles in one side. And the interesting thing is if you have 2 angles in one side, you really have 3 angles in one side, so you could just do an adjustment of one of these rules to get to the other one. So that's kind of a really big important here. So if we're talking about angle side angle, when you look at a triangle, pick any starting angle, okay? So maybe you start here. Then you go to this side. Then you get to the next corner. That would be how angle side angle would look because the side is in between the 2 angles. When it comes to angle side, we would have angle side. However, again, if I were to find this angle right here, then I would have angle side angle. So that is enough to prove congruency as well. So if you can find 3 pieces of identification that has information about 2 angles and at least one side, you have congruent triangles. Okay, so why is it okay if I have 2 angles but not 3 angles? So let's go ahead, and that's more, I think that's the bigger idea, because if you can gather the information about a problem, you're going to be a rock star at solving these. And I'll get to one here in a minute, but why not angle, angle, angle? Okay, so I want you to think of a equilateral triangle. Okay, so all the angles are the same in this, 60 degrees, 60 degrees, 60 degrees. And you take it to a copy machine and you enlarge it. You still have an equilateral triangle, but it is not the exact same size. And when we say congruent, the legs have to be the same length, and this length is definitely not the same as this length. That's still a 60-degree triangle, but it's not the same size 60-degree triangle. The other thing you can think of is picture the state you live in and picture it on a map on your phone compared to a map on the classroom wall. The angles are all the same because you can't make it not the same layout, but obviously it's been enlarged in one spot over another. So angle, angle, angle does not prove congruency. We need at least one side so that we can get information through. Side, side, side works, but angle, angle, angle does not. Okay, and we talked in my last video about why side, side angle doesn't work. I know some people think it's just because it spells a bad word whenever you write it the other way, angle, side, side. It's not. It's actually because of the visual demonstration that I showed in my last video. So keep in mind that there are things that do not prove congruence. And that's what we're about here, is we're about saying, hey, guaranteed these are equal. Not we think they're equal. No, it's guaranteed these are equal. That's what we're going for. So let's say you have 2 triangles. And I may not even be drawing them well. I'm not honestly worried about exactly drawing them perfectly whenever I do these because I'm looking at the big idea. So we have 2 triangles, FGH and JKL. All right, and I am going to mark some information that is given to us. We're given that GH is congruent to KL. We're given that angle GFH, so GFH, is congruent to KJL. And we're given that angle FGH is congruent to angle JKL. And they want us to prove that FH is congruent to JL. Well, in order, before we can ever say sides are congruent, we have to say the triangles are congruent. So, all right, first step of writing a proof, write down all your givens. So we're looking at a picture. And we can say GH, and that's a segment, and KL. We can say GFH. We don't just say angle F. We try to name them with all three letters. Sometimes it's better, especially if your picture has a lot of angles in it, that you use three letters. Is congruent to angle KJL. And we also have that angle FGH is congruent to JKL. And these were all givens. Okay, well, I noticed that that's two angles and then a side, but the side is not in the middle. So angle, angle, side. That's what I marked in pink, right? So could we say side, angle, angle? Yes, we absolutely could. Why do they not write SAA? I'm not sure. We just traditionally do not. So we can now say triangle FGH is congruent to triangle JKL. Oops, I almost wrote a second J. And the reason for that is angle, angle, side. Now that we've said that, now we can say that FH and JL are congruent. And we have to have a reason for that. Well, they are the same part from two different triangles, right? So that reasoning is corresponding parts of congruent triangles are congruent. So if you recall from my last video, I'm like, make sure you say that every single time. That way you understand what CPCTC means. It's not just trying to be a tongue twister. It's just saying, hey, the corresponding parts of the two triangles happen to be the same size. So good options that you have when proving triangles congruent. Ones that will work 100% of the time. Okay, side, side, side. Side, the angle in the middle, then side. Angle, side, angle. And angle, angle, side. And again, I'll draw those in pencil and we'll just make some marks. Okay, so side, 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 angle, side, angle, side, angle, 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 side. So I kind of highlighted those as we went. Those are going to work 100% of the time if you're trying to prove congruence. Okay? These won't work for definitive proof. That would be angle, angle, angle. And that's because it could be a small triangle and the angles could match the same thing as a big triangle. So that's why it's insufficient. And I'm going to write this backwards so it doesn't look like we're writing bad words on our paper, right? Side, side, angle. And again, the reason why side, side, angle doesn't work is because this side length, if I were to swing it in, if I were to do side, side, angle, this side could have been swung back in and still had the same side, side angle, but this triangle right here is not the same as that acute triangle that I drew to begin with. So that's why side, side angle is not definitive proof, because actually, because of the hinging at this vertex, if you swing it out versus swinging that side in, could have created two different triangles. And hey, the fun news is when you get to trig, you get to find both of them, not just one of them, but both of them. So you can find the information about the triangle. It's just the fact that there's two triangles that could exist. So side angle is, I always tell them angle side is a pain in the angle side, right? Because you have to find both. I try to bring some humor into the math room when I can, but hopefully that helps them remember that, yes, side angle, you have to have two different triangles. So make sure you mark your congruency. If you get 3 congruent parts, you can prove those triangles congruent, and therefore your life is a lot faster, because then corresponding parts get you any answer you need.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.